So here we should solve some more JEE Mains previous year questions on the chapter properties of matter. So any doubts if you have in any steps, then please write that in the comments. We shall obviously clarify them in subsequent videos. So here it is told that even below are two statements, one is labeled as assertion A, and the other is labeled as reason B. So the assertion is steel is used in the construction of buildings and bridges. Then is steel is more elastic and its elastic limit is very high. So hence steel is being used since why the Young's modulus of steel is very high. So it is used in construction of buildings and bridges. In the light of our statements, the correct answer. So both A and R are correct, and R is the correct expression of it. Option A is the correct answer. Then it is told a frequency. Yeah. And here it is told the frequency nu of an oscillating liquid drop may depend upon the radius r of the drop, density rho of the liquid, the surface tension S of the liquid as shown. So the frequency that is given as r power a, rho power b, s power c, and the values of a, b, and c respectively are. Values of a, b, and c respectively are. So the dimensional formula should be same on both the sides. Now the dimensional formula for frequency is t power minus 1. That should be same as r means length power a to rho means mass by of volume. It means ml power minus 3 power b, and s is the surface tension which is force by length, which is mlt power minus 2 by length whole power c. So length will cancel out. Then therefore I can say this is L power A to M power 2, M power 2, and then E actually. This will not be M power 2. This will be to M power B plus C, M power A minus 3B, M power B plus C, and into T power minus 2C. That will be equal to T power minus 1 into M power 0, M power 0. So therefore M power 0, it means that T plus C, that should be 0. M power 0, it means A minus 3B, that should be 0. Minus 2C, that should be minus 1. So it means C should be equal to half. So B should be minus half. A should be 3 times B, that is 3 times minus half, that is minus 3 by 2. So A is minus 3 by 2, B is minus 1 by 2, C is 1 by 2. Therefore, the values of A, B, and C are minus 3 by 2, then minus 1 by 2, and 1 by 2. Option B is the correct answer. And here it is told 100-meter long wire having cross-sectional area A, which is 6.25 into 10 power minus 4 meter square. And the Young's modulus is 10 power 10 Newton per meter square. Subjected to a load of 250 Newton. So now there is a 100-meter long wire. 100-meter long wire is there. Area of cross section is this. Young's modulus is this. So it is subjected to a load. Subjected to a load that is F, that is 250 Newton. Then the elongation in the web, that is delta L, that will be how much? And so we know that F is equal to YA by L into delta L. So delta L will be equal to FL by AY. Delta L, that will be F, that is 250 Newton into length, where that is 100-meter long, and area of cross section, that is 6.25 into 10 power minus 4 meter square. And Young's modulus is 10 power 10. 10 power 10. So here the we can write this would be 0.25 into 10 power 3. So this is 10 power 5 divided by 6.25 into 10 power 10 minus 4, 6. So 25 is just 625. So this will be equal to 1 by 25 into 1 by 10. So it is 1 by 250. Which means I can say this will be into 2 into 2 I can do, into 4 into 4 I can do. So that will be 4 by 1000. So which is 4 into 10 power minus 3 meter. So 4 into 10 power minus 3 meter is the elongation of the wire. So option B is the correct answer. And here it is told there is an air bubble. There is an air bubble of radius 1 millimeter in a liquid of surface tension S, that is 0.075 Newton per meter. And the density is surface tension is this, and the density, that is 10 power 3 kg per meter cube, and the depth of 10 centimeter below the free surface. An air bubble is there of radius 10 power minus 3 meter. Surface tension, that is 0.075 Newton per meter, and the density is 10 power 3. And it is at a depth reach of 10 centimeter below the free surface. And the amount by which the pressure inside the bubble is greater than the atmospheric pressure is. Then the amount by which the pressure inside the bubble greater than the atmospheric pressure. So P minus P naught, that we know, that is 4S by R. So it is 4 into 2.075 by R. Okay, so it is pressure minus pressure inside minus pressure outside, that is 4S by R. And the pressure outside, that is equal to P naught plus rho GH. Since it is at a depth of 10 centimeter below the free surface, so that will be Okay. That means that Pn minus the pressure outside. So the pressure outside the air bubble, that is P naught plus rho gh, that is equal to 4s by r. So therefore P inside minus the atmospheric pressure, that is given as 4s by r plus rho gh, which will be 4 into s, that is 0.075, divided by r, that is 1 millimeter, means 10 power minus 3 meter, 10 power minus 3 meter plus rho gh, that is plus 10 power 3 plus 10 power 3 into g, to g, that is 10 into h, that is 10 centimeter, it means 0.1 meter, I can say 0.1. Therefore, the pressure inside minus the atmospheric pressure, that will be equal to, therefore the pressure inside minus the atmospheric pressure, that will be equal to 4 into 0.075 divided by 10 power minus 3, which means into 10 power 3. Then plus this will be 10 power 3. This will be 10 power 3 into 4 5s are 20, and 4 so 28 30. So this will be 0.3 plus 1. So this will be 1.3 into 10 power 3. It means it is 1300 uh, uh, Pascal. So the answer will be 1300 Pascal. So then here it is told the elastic potential energy stored in a steel wire of length 20 meter, then the elastic potential energy that is stored in a steel wire of length, that is 20 meter, is stretched out to 2 centimeter. So it is being stretched out to 2 centimeter. The elastic potential energy, that will be how much? So that will be 80 joule. That is 80 joule. The cross-sectional area of the wire will be how much? So given the Young's modulus of the steel, that is 2 to 10 power 11 Newton per meter square. Therefore, this potential energy, that I can write it as half into YA by L into delta L whole square. So this delta L, that is 2 centimeter. So this will be half into half into, okay, the cross-sectional area of the wire that you have to find. So A, you have to find out. So the Young's modulus, that is 2 into 10 power 11 into 8 divided by the length, that is 20 meter, whole into delta L is 2 centimeter. Delta L is 2 centimeter, means I can write 0.02 meter also. So this will be 0.02 whole square. And the potential energy is given as 80 joule. This 2 will get cancelled. Then I can say that A into this, I can write 2 into 10 power minus 2 is 4. 4 into 10 power minus 4 into 10 power 11, that is equal to 20 into 80. Means that 4 into A into 10 power 6, no, 10 power 7, since 11 minus 4, that is 7. That is equal to 1600. So therefore A will be equal to 1600 divided by 4 to 10 power minus 7. So therefore the area of cross section of the wire, that is 400 into 10 power minus 7, is 4 into 10 power minus 5. So this much meter square. Now we have to find it in millimeter square. So 1 meter square, that is, I can say 10 power 6 millimeter square. So it means 2 into 4 into 10 power minus 5 into 10 power 6 millimeter square. So this will be 40 millimeter square. So 40 millimeter square is the required cross-sectional area of the wire. And here it is told glycerin of density 1.25 into 10 power 3 kg per meter cubed. Glycerin, so that glycerin that is flowing through the conical section of a pipe. Okay. So we can have a conical section. So the conical section of the pipe, the area of cross section of the pipe at its end. So here the area is 5 centimeter, and here 10 centimeter square, and here the area is 10 centimeter square. And the pressure drop across its length is 3 Newton per meter square. Pressure drop across this length. So here the area is high, the velocity will be less, so the pressure will be higher here. Let's say P1, P2, let's say. So P1 minus P2, that is equal to half into rho into meters P1 square minus V2 square. Area is high, the velocity will be low. V2 square minus V1 square. Here we are using the Bernoulli's principle. Bernoulli's principle. And here you have to find the rate of flow of glycerin to the pipe. Rate of flow of glycerin through the pipe is x into 10 power minus 5 meter cube per second. That means it is the volume flow rate, volume by time. That is this, and the value of x is. So the glycerin density they give. The pressure drop that is given as, because it is flowing like this. So the pressure drop that is 3 Newton per square, and that is equal to half into rho, that is 1.25 into 10 power 3 into V2 square, V1 square, this 10 square minus 5 square. Rate of flow of glycerin through the pipe. Sorry. So the rate of flow, we can say this dV volume by time. Volume means it is area into x by t. Area of cross section by t. So area into velocity, that we have to find out. It means here A1 V1 that will be equal to V2 V2. Now you can say that area, that is 10 centimeters square here. So here if the velocity is V1, here if the velocity is V2, then I can say 10 centimeters square into V1, that will be equal to 5 centimeters square into V2. Now therefore centimeter square will cancel, 5 to 10, so V2 that is equal to 2 V1. V2 that is equal to 2 V1. This one here, instead of writing this we have to write 2 V1 whole square, that is 4 V1 square, minus V1 square, that is 3 V1 square. Therefore 3 V1 square is 3 V1 square into, so 3 V1 square into 1.25 by 2 into 10 power 3, that will be equal to 3. So 3 and 3 will get cancelled. So V1 square that will be equal to 2 by 1.25 into 1 by 10 power 3. 2 by 1250. Rate of flow of the glycerin. So I can say 267. So V1 that will be equal to 1 by 25 meter per second. So therefore, the rate of flow of the glycerin to the pipe, rate of flow of the glycerin through the pipe, that is A1 into V1. Therefore now A1 into V1, that is fine. So now A1 that is A1 that is 10 centimeters square. A1 that is 10 centimeters square. So 1 by 25 meter per second This is 1 centimeter square. I can say that is 10 power minus 4 meter square. So this is 10 into 10 power minus 4 divided by 25. So this is 5 by 25, 25 by 10. So this is 0.4 into 10 power minus 4, or you can say 4 into 10 power minus 5 meter cube per second. 4 into 10 power minus 5. So the value of x will be 4. 4 is the answer. Here it is told the surface tension of a soap solution. The surface tension of a soap solution is 3.5 into 10 power 2 to Newton per meter. Surface tension of a soap is 3.5 into 10 power minus 2 Newton per meter. The amount of work done required to increase the radius of the soap bubble. Work done to increase the radius of the soap bubble from 10 centimeter to 20 centimeters. This dash into 10 power 4 joule. Therefore, pi will be equal to 22 by 7. So we know that work done is equal to the surface tension into change in the surface area. So that is 3.5 into 10 power minus 2 into change in surface area. So uh, Powell surface area, that is equal to 8 pi r square. Since for soap bubble we have two surfaces. One is the inside surface and one is the inner surface. One is the outer surface. This will be 8 pi r square. This will be 8 pi into 20 centimeter means 0.2 meter, and 10 centimeter means 0.1 meter. 3.5 into 10 power minus 2 into this is 8 pi to r square, that is 0.2 whole square minus 0.1 whole square. 0.2 whole square minus 0.1 whole square. Okay. This will be 3.5 into 10 power minus 2 into 8 to pi 22 by 7 into this will be 0.2 plus 0.1, that is 0.3 into 0.2 minus 0.1, that is 0.1. This will be 7 5s are 35. 0.5 into 8, that is 4. 4 into 22 into 0.03, which is 88 into 0.03. So this is 8, it is 6, 3 8s are 24. 3 is 24, 264, so 2.64 joule. I can say it is, yeah, power minus 2 is 4. 4 into 22 into, sorry, this is 4 into 22 is 0.03 into 10 power minus 2. So this I can say it is 4 into 22 into 3 into 10 power minus 4 joule. So this 12 2s are 24. 12, 3 4s are 12. So 12 2s are 24, 24, 24, 264 into 10 power minus 4 joule. So 264 into 10 power minus 4 joule is the correct answer. Then it is told where of density, that is 8 into 10 power 3 kg per meter cube. So that where is stretched in two clamps. In two clamps, the where is 0.5 meter apart. The extension developed in the where is the fundamental vibration of the where is. Is stretched between two clamps. The extension is delta L, that is 3.2 into 10 power minus 4 meter. The Young's modulus y, that is 8 into 10 power 10 Newton per meter square. The fundamental frequency of vibration of the wire, that is nu naught, that we have to find out. So nu naught, which is the fundamental frequency of the vibration of the wire, that we have to find out. Here the fundamental frequency that is given as, so when it's clamped, so then here so in the case of fundamental frequency, we can say that lambda by 2, that will be equal to L. That is equal to L. So nu naught fundamental frequency, that is V by lambda. So V is root over 1 by lambda, that is 1 by 2L into root over T by mu. Mu is mass by length, mass per unit length. So mass is density into volume, which is area of cross section, into length divided by length. So it is rho into A. So rho A I can write. So from here, delta L that has been told. So we can say that, you know, that that is the tension force that is created in the wire, the tension force. So T is equal to F, T is equal to YA by L into delta L. So from here we can find out the value of T by A. T by A will be y by L into delta L. Y by L into delta L. So now, therefore, the fundamental frequency of vibration, that is equal to 1 by 2L to root over 1 by rho into T by A, that is y by L into delta L. Therefore, this will be 1 by 2L. Then, so the wire is placed between these two clamps, having the separation is 0.5 meter. This is 0.5. So this will be root over y. This is 8 into 10 power 10 into delta L. That is 3.2 into 10 power minus 4 divided by Young's modulus 8 into 10 power 10, 8 into 10 power 10, 3 point, Young's modulus is 8 into 10 power 10, into 10 power minus 4 divided by rho. Rho is 8 into 10 power 3. And 3 into L, L is 0.5. This much Hz it will come. Now we have to calculate this. 8 it will cancel. Then this will be 1 by 2. 0.5 means 1 by 2. That 2 will go up. So this will be 1 by 2 into 0.5, that is 1. To root over, this is 2.2, that is 6.4 into 10 power 10 minus 4, that is 6. 6 minus 3, that is 3. I can say this will be root over 64 by 10, 10 power 3. So this will be 10 power 2. So this will be 8 is the 64. So this will be 80 Hz. 80 Hz is the fundamental frequency of vibration of the wire. And here it is told the length of a wire becomes L1 and L2 when 100 Newton and 120 Newton tensions are applied respectively. The length of a wire becomes L1 and L2 when so there is a wire length of a wire, this will be L1 when tension of 100 Newton is applied, that is T1. The length of the wire, that will be the L2 when the tension T2, that is 120 Newton, is applied. So it will be. Now it is told if 10 L2, that is equal to 11 L1, the natural length of the wire will be, the natural length of the wire is L1 by X. 1 by X into L1. So then the value of X will be how much? So we know that force is equal to Kx. So T1, that will be equal to K into, suppose the natural length is L. So here the extension X1, that is L1 minus L. Here also the extension X2, that is L minus L2. So here we are assuming that the natural length of the wire, natural length be L. So then T1 that will be equal to A into T1 that will be equal to K into delta X, K into X1 that is L1 minus L, and T2 that will be equal to K into where K is nothing but K is 0 YA by L. K is Y by L. Where L is the natural length, A is the area of cross section, Y is the Young's modulus of the wire. So this will be constant only. T2 will be equal to K into L2 minus L. Therefore, I can say 100 that is equal to K into L1 minus L, and 120 that is equal to K into L2 minus L. So if we divide these two, then we will get 10 by 12 that is equal to L1 minus L by L2 minus L. Now here we can say L2 that is 11 L1 by 10. Therefore, this will be 2 5 is 10, 2 6 is 12. So 5 by 6 that is equal to L1 minus L divided by L2 that is 11 L1 by 10 minus L. So now therefore 5 into 11 L1 by 10 minus L that is equal to 6 into L1 minus L. So this will be 55 L1 by 10 minus 5L that is equal to 6L1 minus 6L. So this will be 6L minus 5L that is L, which is the natural length, that will be 6L1 minus 55L1 by 10. This 5 to the 10, 5 11s are 5. So this will be 6 to the 12, 12L1 minus 11L1 by 2 is equal to L1 by 2. So L is equal to L1 by 2, which is given as L1 by X. So therefore X will be equal to 2. So X will be equal to 2. So 2 is the answer. Then here it is told the figure below shows a liquid being pushed out of the tube by a piston having area of cross section. Area is 2 centimeters square. The area of the cross section at the outlet here, the area of cross section, that is 10 millimeters square. If the uh, piston is pushed at a speed of V1, let's say 4 centimeter per second, then the speed of the outgoing fluid will be how much? V2 in centimeter per second. That you have to find out. So here we can apply the equation of continuity. Equation of continuity that is says that A1 V1 that will be equal to A2 V2. So A1 is 2, V1 is 4. This is in centimeter square. This is in centimeter per second, and A2 also 10 millimeter square. So this will be, so 1 millimeter is 0.1 centimeter, means 10 power minus 1 centimeter. It means that 1 millimeter square that will be equal to 10 power minus 2 centimeter square. So therefore now 10 millimeter square, 10 millimeter square, that is equal to 10 into 10 power minus 2, is 0.1 centimeter square. So this will be 0.1, this is in centimeter square into V2. Now V2 that we have to find out in centimeter per second. Centimeter square will cancel out. So V2 will be equal to 2 into 4, that is 8 by 0.1 centimeter per second. So this will be 80 centimeter per second. This is V2. Speed of the outgoing fluid, that is 80 centimeter per second. So that is the answer. So here it is told two wires, each of radius 0.2 centimeter. Here the radius R1 is 0.2 centimeter, R2 is 0.2 centimeter also, and they have negligible mass, one made of steel and the other made of brass, are shown in the figure. The elongation in the steel wire is we have to find out is delta L1 that we have to find out. So now here this is mg, g is 10, so I can say this is 11.4 Newton. Here this is mass is 20 Newton. So on the steel wire, the net force on the steel wire, that is 20 plus 11.4, that is 31.4 newtons. Now to find delta L. So we know that force is equal to YA by L into delta L. So therefore the elongation in the steel wire, that is delta, that is FL by AY. Force, that is 31.4 into L, FL by AY, that is L, that is 1.6 meter. The area of cross section is pi r square. It's 3.14 into r square, which is 0.2 centimeter, means 2 into 10 power minus 1 centimeter. That is the radius, means that is 2 into 10 power minus 3 meter. So the r square that will be 4 into 10 power minus 6. This is r into Young's modulus, which is 2 into 10 power 11. So this is 31.4 into 1.6 divided by 4 into 2 into 3.14 into 10 power 11 minus 6. Delta L 3.14 point will get cancelled. So this into 10 I will get. And 2 for the 8, 8 plus the 16, 0.2. This is 2 into 10 power minus 5 meter. Or I can say that is 20 into 10 power minus 6 meter also. So this is the amount of extension in the steel. The amount of extension in this, the amount of elongation in the steel wire, that is 20 into 10 power minus 6. 10 to 10 power minus 6 meter. That is the answer. And then here it is told an air bubble of diameter. Here bubble is there of diameter 6 millimeters. So it means the radius of the air bubble is 3 millimeter. So it will rise steadily through a solution of density 1750 kg per meter cube. It will rise steadily by the terminal velocity, that is 0.35 centimeter per second, or I can say it is 3.5 into 10 power minus 1 means 10 power minus 3 meter per second. The terminal velocity. The coefficient of viscosity of the solution in Pascal second is the coefficient of viscosity of the solution that we have to find out. So air bubble is there. So it's the density of the air, that is approximately zero only, since why it is much less as compared to the density of the solution. So hence we can ignore the density of the air also. So here we know that the terminal velocity, that is equal to, given as 2r square to rho minus sigma g by 9 eta. So this will be 2 into r square. R is 3 millimeter, means 3 into 10 power minus 3 meter, 3 into 10 power minus 3 whole square into g. G is 10 to rho minus sigma, that is 1750 minus approximately 0, I can say. Here it is told to neglect the density of air also. So by 9 eta, that is terminal velocity, that is 3.5 into 10 power minus 3. So therefore, eta I have to find. So eta will be 2 into 9, this is 9 to 10 power minus 6 into 10 into 1750 divided by 9 into 3.5 into 10 power minus 3. So this is the value of the eta, which is the coefficient of viscosity of the solution that we have to find out. So 9 and 9 will get cancelled. So this will be 7 5s are 35, 7 2s are 14, 7 5s are 35. 0. This is 1 by 2, so this will become 4. 4 into 250 into this will be 10 power 1 minus 6 plus 3. So this will be again 25 for the 100, so this will be 10 power 3 plus 1 plus 3 minus 6. So 6 and 6 will cancel, so 10 power 1, that is 10 Pascal second. So 10 Pascal second, so 10 is the answer, which is the required coefficient of viscosity of the solution. Let me told a metal block of mass m is suspended from a rigid support through a metal wire of diameter 14 millimeter. So it means the radius is 7 millimeter for this wire, and one metal block of mass m is suspended from it. The tensile stress developed in the wire under equilibrium state. The tensile stress, which is sigma, which is force per unit area, that is given as 7 into 10 power 5 Newton per meter square. So then the value of mass m in kg is value of mass m is how much is m I have to find out, and take g as 9.8 and pi as 20.7. So therefore here obviously the force that is acting, that is mg. So mg by area of cross section, that is pi r square, that is obviously the tensile stress, force per unit area, that will be obviously the tensile stress, and that will be equal to that will be equal to that will be equal to the mg by r square. And that tensile stress is 7 into 10 power 5. So therefore m into g, that is 9.8 divided by pi, that is 22 by 7 into r square, 7 millimeter, that is 7 into 10 power minus 3 meter. So this is 7 into 10 power minus 3 whole square, that is equal to 7 into 10 power 5. Now therefore m will be equal to 7 into 10 power 5 into 22 by 7 into 7 times 49 into 10 power minus 6 divided by 9.8. So this will be 7 and 7 will cancel out. Then 49 2s are 98, so 0.2. So this is 2 by 10. So this will be 5. Therefore, m is, this is 10. It is 22 into 10 power 5 minus 6 by 0.2. So will be 2 ones are, this is 2 11. So this is 11 into, this is all again 1 by 10. This will be 10 power 6 minus 6, that is equal to 10 power 0 is 1. So m is equal to 11. So 11 kg is the required mass of the metal block. 11 is answer. Here it is told a steel rod that has a radius. A steel rod, it is having a radius 20 millimeter, means 0. Which is 20 into 10 power minus 3 meter. The length, that is 2 meter. 2 meter is the length, and a force of 62.8 kilonewton stretches it along its length. To stretch it along its length, Young's modulus of the steel. So there will be some extension delta L produced in the wire. So Young's modulus of the steel, that is 2 into 10 power 11 Newton per meter square. So then the longitudinal strain, that will be how much? So epsilon, that is delta L by L, that one we have to find out. So we know that stress, that is given as Young's modulus into strain. So strain will be equal to stress by Young's modulus. So now stress, that is force by area divided by y. So that will be F by AY. This value we have to find out. Now the force is 62.8 kilonewton, means it is 62.8 into 10 power 3 Newton. So it is 62.8 into 10 power 3 Newton divided by A. A, that is pi r square. That is 3.14 into pi r square. R square, that is r into 2 into 10 power minus 2 means 2 into 10 power minus 2 whole square. Pi r square to y. Y is 2 into 10 power 11. So this is the longitudinal strain that is produced in the web. Longitudinal strain that is produced in the web. So this will be, so now this one we can cancel. Point, this is going to cancel. So 314 into 2 is 628. So 20 I will get here. So 2 tens are 20. So this is 10 power 4 divided by, this is 4 into 10 power minus 4 into 10 power 11. So this will be 1 by 4 means 0.25. Therefore, the longitudinal strain, that is 1 by 4 into 10 power 4 plus 4 minus 11. This will be 0.25 into 10 power minus 3. So this will be 25 into 10 power 25 into 10 power minus 2 minus 3, which is 25 into 10 power minus 5. 5 into 10 power is 5. So the longitudinal strain produced in the wire is 25 into 10 power minus 5. So 25 is the answer. Here it is told the surface of water in a water tank of cross-sectional area 750 centimeters square, top of a house, is each meter above the tap level. There is a water tank. The surface of water in a water tank, the area of cross section is 750 centimeters square. Surface of water on the top of a house is each meter above the tap level. So here we have the tap. So this is the surface is each meter above the tap level. The speed of water coming out to the tap of cross-sectional area A, to suppose that is 500 millimeter square, is V2, that is 30 centimeter per second. 30 centimeter per second. Then at that instant, dH by dt, that is x into 10 power minus 3 meter per second. The value of x is how much? So dH by dt, it means the rate at which the height of the water level will change. So we can say that A1, that is equal to A2, C2 by using the equation of continuity. And here also the outside pressure is P naught, which is atmospheric pressure. So I will say P naught plus half. Here the velocity is V1. V1 is only dh by dt. That only we have to find, since that is given as x into 10 power minus 3 meter per second. Then x value I have to find out. So P plus half, P naught plus half rho V1 square plus rho gh, that is equal to P naught plus half rho V2 square plus rho g, which is 0 here if we take the ground level here only. P naught and P naught will get cancelled. This also will be 0 only. So it means rho gh, that is equal to half rho into V2 square minus V1 square. So rho and rho also will get cancelled. And then here actually the area already that they gave. So I can say area, that is 750 centimeter square, into A1, that is so V1, that is dh by dt, that is equal to A2, that is 500 millimeter square, which is equal to 500 into 10 power minus 2 centimeter square. It means 5 centimeter square into V2. V2 is 30 centimeter per second. Centimeter square will get cancelled, and 0 will also get cancelled. So then 5 3s are 15, 15 5s are 75. So dh by dt, that will be equal to 1 by 5 centimeter per second, which is 0.2 centimeter per second, which is equal to 0.2 into 10 power minus 2 meter per second, which is 2 into 10 power minus 3 meter per second. So obviously the value of x will be 2. 2 is answer. Here it is told a certain pressure P is applied to 1 liter of water. 1 liter water is there, and a certain pressure P is applied, and 2 liter is applied to 1 liter of water and 2 liter of water also separately. The same pressure is applied. Water gets compressed by 0.01%. So here actually water is not there. A 2 liter of liquid is there. And it is told water gets compressed by 0.01%, means delta V by V, or minus delta V by V. Since we have to find the percentage compression, so that is 0.01%. And here the change in the decrease in the volume or the compression is 0.03%. The ratio of the bulk modulus of water to that of the bulk modulus of the liquid, that is 3 by x. The ratio of the bulk modulus of water to that of the bulk modulus of the liquid, that is 3 by x. The value of x is. Now bulk modulus, that is given as minus delta P by delta V by V. So therefore the bulk modulus of water, I can say, that is the change in the pressure applied, that is P, by 0.01%, means 0.01 by 100. So this will be 100 P by, this is 1 by 100. So this is again 100 square, 10 power 4. 10 power 4 times P. And the bulk modulus of the liquid, that will be equal to P by okay. The change in the pressure is P only, but the fractional change in the volume, which is the compression, that is 0.03 by 100. So this will be 10 power 4 p by 3 by 100 square 10 power 4 p by 3. So therefore, the bulk modulus of water, that is 10 power 4 p, is to the bulk modulus of the liquid, that is 10 power 4 p by 3, that is equal to 3 by x. Well, therefore, I can say this to be 10 power 4 p by 10 power 4 p by 3. So 3 will go up, that is equal to 3 by x. So these two will cancel. So 3 by 1, that is equal to 3 by x. So x is equal to 1. So therefore, the required value of x is 1. 1 is the answer. Then here it is told a thin rod having a length of 1 meter. The thin rod is there, which is having a uniform length of 1 meter, and the area of cross section is 3 into 10 power 6 meter square, and that is suspended vertically from one end. The rod is cooled from 210 degrees Celsius to 210 degrees Celsius to 160 degrees Celsius. It is being cooled down. Then after cooling, a mass M. After cooling it, a mass M is attached to the lower end. Mass capital M, that is attached to the lower end of the rod, such that the length of the rod again becomes 1 meter. So here there is some extension, that is delta L. Here the initially the length was 1 meter. The finally the length will be slightly decreased since it is being cooled. So L final, now L final plus delta L, that is equal to the L initial, it has been cooled. Means the initial length that was 1 meter. So the final length, that will be 1 meter minus delta L. Then here it is told the Young's modulus and quotient of linear expansion of the rod are this and this. So Young's modulus is 2 into 10 power 11 Newton per meter square. And the quotient of linear expansion, which is alpha, that is 2 into 10 power minus 5 per Kelvin, respectively. Then the value of M will be how much? The value of this M will be how much? Now the value of this M that we have to find out. Now final length, that is equal to initial length into 1 plus alpha delta t, or delta theta, I can say. Del alpha delta theta, where theta is the where delta theta is the change in the temperature. Therefore, L final, that is 1 meter, L initial is 1 meter into 1 plus alpha, that is 2 into 10 power minus 5 into delta t, that is 160 minus 210. So that will be 1 plus 2 into 10 power minus 5 into, which will be 0, which is minus 15 inches. This is 1 minus 100, it's 10 power 2 into 10 power minus 5, which is 1 minus 10 power minus 3. One minus 0.001. This much meters. Means it is 0.999 meters, which is the L final. So therefore, delta L, for delta L, that is equal to L final L initial minus L final, that is 1 minus 0.999, which is 0.001 meters. Just delta L. So now we can say that tension force that is applied, force equal to YA by L into delta L. So therefore, and here the force that is applied, that is equal to mg only. G is the force, so mg that is equal to YA, area of cross section, A by L. It's L final only that we have to take, and into delta L is 0.001. Then m we have to find out the value of the mass m. So here this m that will be equal to y a by 0.999 into 0.001 into 1 by g, that is 10. That will be y. Y, that is 2 into 10 power 11, 2 into 10 power 11 into a, that is 3 into 10 power minus 6 into 1 by 999, 1 by 10. Y a by L final into delta L by g. Therefore, the mass m, that is 6 into 10 power 5 I, this I can write one. This is approximately 10 power 3 only. So 10 power 3 into 10, that is 10 power 4. So this is approximately 60 kg. So 60 kg is the approximate mass of this of, of this mass m. So here it is told that a metal block of base area 0.2 meters square is placed on a table as shown. A liquid film of thickness, the liquid film is having thickness 0.25 millimeter. 0.25 millimeter, and the area is 0.2 meter square. The block is pushed by a horizontal force 0.1 Newton and moves with a constant speed, let's say v. If the viscosity of the liquid, viscosity eta, that is 5 into 10 power minus 3 pi means quasi, then the speed of the block is dash into 10 power minus 3 meter per second. So this velocity you have to, the speed you have to find out. So we know that force, so the velocity of the lowermost layer, that will be zero only. So it means the viscous force will act opposite to the applied force. And so the viscous force should be equal and opposite to the applied force. Since why? Since it is told that the block is moving with a constant speed. Block is moving with a constant speed. So hence the speed or the so it means the acceleration is zero. It means the net force acting on the block is zero. So it means the viscous force will be should be equal and opposite to the applied force. Now we know that the viscous force, that is equal to eta A dV by delta V by delta X, I can say. So the viscous force that I can write, that is equal to eta into A into delta V, that will be V, and delta X, that will be the thickness. Let's call it as D. So therefore V I have to find out. So V will be F, the viscous force, into D by eta A. Therefore the speed, that is viscous force, that is 0.1 Newton into the D, the that is the thickness, which is 0.25 into 10 power minus 3 Newton, divided by eta, that is 5 into 10 power minus 3, and into A which is 0.2 meter square. From here we can say 2 5 is 10, so this will be 1, and this is 10 power minus 3 get cancelled. So this is 0.1 into 0.25 means it is 25 into 10 power minus 3 meter per second. So the answer is 25. And here it is told a spherical block of liquid splits into 1,000 identical spherical drops. So there is one spherical drop of a liquid that will split into 1,000 spherical drop. 1,000. If Ui is the surface energy of the original drop, and Uf is the total surface energy of the resulting drops, so ignoring the, then the Uf by Ui value is 10 by x, in the value of x is. So Ui is the surface energy of the original drop, that is S into area, where S is the surface tension and A is the surface area. So surface area, that is equal to 4 pi r square. The U final, that is surface tension, into the final area. The initial area is 4 pi capital R square. Now final area, that is equal to 1,000 into 4 pi small r square, where r small r is the radius of each identical spherical drops. So now we can conserve the mass. So if we conserve the mass, and since density is same, so the volume will remain conserved. So the the initial volume that is equal to the final volume of all the drops. So V initial, that is 4 by 3 pi r cube, that is equal to 4 by 3 pi small r cube into 1000 to this 10 power 3. 4 by 3 by 4 by 3 by cancel, so r is equal to 10 r. Since if you take the cube root on both sides, then r will be 10. So this I can write s into 4 pi into r square, r is 10r whole square, is equal to 100 into s into 4 pi r square. And the final surface energy, that is equal to s into 1000 into 4 pi r square. So now therefore u final by u initial, that is equal to, this is 1000 into s into 4 pi r square divided by u initial, that is 100 into s into 4 pi r. 4 pi r square will get cancelled, s and s will get cancelled. So this is 10 by 1, is equal to 10 by x. So therefore x is equal to 1. So 1 is the answer. 1 is the required answer. And here it is told, as shown in the figure, in an experiment to determine Young's modulus of a where the extension load curve is uh, plotted. Extension versus load curve is plotted. Then the curve is a straight line passing through the origin. Curve is a straight line passing through the origin and makes an angle of 45 degree with the load axis. Shown in the figure in an experiment to determine Young's modulus of OF. So we know that load and extension. So load is F and Y, F is equal to YA by N into delta N. So F versus L graph. So the slope will give us the value of YA by N. The curve is a straight line passing through the origin and makes an angle of 45 degrees. So the slope is tan 45, that is equal to 1. The length of the wire that is told 62.8 centimeter, means it is 0.628 meters, and the diameter, it means it is 4 millimeter, means the radius of cross section of the wire, that is 2 millimeter. So therefore the area of cross section, that is equal to pi r square, is 3.14 into r square. So r I can write 2 into 10 power minus 3 meter. This will be 2 into 10 power minus 3 whole square, meter square. So therefore now y a by L, that will be equal to so y is x into 10 power 4. into A. So Young's, so the value of X will be how much that we have to find. So YA by L value is 1. So X into 10 power 4 into this is 3.14 into this is 4 into 10 power minus 6 into 10 power minus 6 divided by by L, it is 0.628. That is equal to 1. So therefore now so we can write 314 into 0.01. This is 314 into 0.001. 0.002 actually. Right, 2 into 3.314, I can take 100, 628. So this will be x into 10 power 4 into this is 10 power minus 2. So into 4 into 10 power minus 8 divided by 2 into 10 power minus 3 is equal to 1. Into the 4. So therefore I can say x into 2 into 10 power 4 minus 8 plus 3, that is equal to 1. So it means x will be equal to, this will be 7 minus 8, 1 by 2 into 10 power minus 1. This 10, so it is 1 by 10, so 10 will go, so x is equal to 5. So 10 by 2, that is 5. So the value of x is 5. 5 is the answer. And here it is told a spherical ball of radius, spherical ball is there, it is having radius 1 millimeter, which is 10 power minus 3 meter, and density rho, that is 10.5 gram per centimeter cube. 10.5 gram per centimeter cube means 10.5 into 1 gram means 10 power minus 3 kg, and 1 centimeter cube means 10 power minus 6 meter cube. So this will be 1000 into this. So 10.5 into 10 power 3 kg per meter cube is dropped in glycerin. Is dropped in glycerin of coefficient of viscosity 9.8 poise. 9.8 poise. Now 1 poise equals to, you can say, okay, so 1 point, okay, and the density of glycerin, that is sigma, that is 1.5 gram per centimeter cube, and so which is 1.5 into 10 power 3 gram per centimeter, sorry, kg per meter cube, and rho, that is the density of the ball, that is 10.5 into 10 power 3 kg per meter cube, and the viscous force on the ball when it attains constant velocity. So the viscous force is acting and the buoyancy force is also acting, and the weight of the ball is also acting. It is downwards, and the buoyancy force of the upthrust is that, and the viscous force, these both are acting upwards. So when it is moving with a constant velocity, which is the terminal velocity, then you can say the viscous force plus the buoyancy force, that will be equal to the weight of the ball. So the viscous force, that will be equal to mg minus fb, which is fb is the buoyancy force of the upthrust. So fb, that is v into sigma into g, that is v is m by rho, I can say m by rho into sigma into g. So this will be mg into 1 minus sigma by rho. And that value has been given as 3696 into 10 power minus x Newton. So then the value of x we have to find out. Now, one was actually one twice, so it is the CGS unit of viscosity, which is equal to 1 gram per centimeter per second. So that will be equal to 10 power minus 3 kg divided by 10 power minus 2 meter into second. So this will be 10 power minus 1 kg per meter per second, which means 10 power minus 1 Poisson. Which is PL. So the SI unit of viscosity is Poisson and the CGS unit of coefficient of viscosity is Poisson. So it means that 1 Poisson that is equal to 10 Poisson. Now, so therefore we can say that mg into 1 minus sigma by rho, that is equal to the viscous force. So therefore mg, that is mg spherical ball of radius this, so it means 4 by 3 pi r cube into g into rho into g, that is into 1 minus sigma by rho, that is equal to the viscous force. Is 3696 into 10 power minus x. So therefore, instead of 4 by 3 into 3.14 into pi, now pi we have to take 22 by 7, it has been told. You have to take 22 by 7 only. 22 by 7 into r. R is 1 millimeter, so 10 power minus 3 whole cube into density. So that is 10.5 into 10 power minus 3, sorry, 10 power 3. 0.5 into 10 power 3 into g. G is 9.8 into 1 minus rho sigma by rho minus sigma by rho. That is 1.55 10.5. That is equal to 3696 into 10 power minus x. So here, see point I can cancel. So 15, 7 is 105. 30, 15, 30, 10. So 1 minus 1 by 7. So this will be 3. This will cancel. 3 3s are 9, 3 5s are 15. 7 5s are 35. 0.5 into 4, that is no, 0.5 into 22, that is 11, into 10 power minus 9 to 10 power 3 into 9.8 into 1 minus 1 by 7 is 6 by 7. That is equal to 3696 into 10 power minus 6. Now 7 ones are 7, 7 fours are 28. Now this is 1.4 into 6 fours are 24. 6 into 44. 44 into 6 fours are 24. 684, 8.4 into 10 power minus 6. That is equal to 3696 into 10 power minus x. Okay, so now 44 into 84 that we can do, that is 4 for just 16. 4 is just 32, 33, 4 for just 16, 32. So this is 3696. So this is this I can write 3696 into 10 power minus 7 is equal to 3696 into 10 power minus x. So it means x will be equal to 7. So x is equal to 7. So 7 is the answer. Here it is told then it is told that the assertion is clothes containing oil or grease stains cannot be cleaned by water wash because the angle of contact between the oil and grease and water is obtuse. So here the thing is due to the obtuse angle of contact, the water doesn't wet the oiled surface, and so through water wash we can't remove the oil of the grease. So hence the clothes containing oil or grease stains can't be cleaned by water wash since the angle of contact between the oil or breeze with the water is obtuse. So if it had been an acute angle, then it would have been clean, but since it is an obtuse angle, so we can't clean it. So here both A and R are true, and R is the correct explanation of it. So option A is the correct answer. When it is told if the length of a square is made double and radius is half of its respective values, then the Young's modulus of the material of the wire will be the length of a wire is made double. Length of a wire is made double, and the radius is half its respective values. The length it is doubled, the radius it is halved. Radius is halved of its respective values. Then the Young's modulus of the material of the wire it will remain same only, since by the Young's modulus it depends on the nature of the material. It depends on the material only, and it is in independent of the length or the shape or the size of the square. So option A is the correct answer. When it is told a pressure pump has a horizontal tube where it is told a pressure pump has a horizontal tube of cross-sectional area 10 centimeters square. So a pressure pump that has a horizontal tube of cross-sectional area 10 centimeters square for the outflow of water at a speed of let's say we call it as V1, that is 20 meter per second. The force exerted on the vertical one just in front of the tube. How much force exerted on the just in front of the tube, which stops water, which stops water horizontally flowing out of the tube. So it will stop the water horizontally flowing out of the tube. So it means the water will just flow downwards after hitting this vertical wall. Then how much force is exerted by the wall? So the force that is exerted, that is obviously equal to change in momentum by time in interval, change in momentum by time interval. So the momentum I can say that is equal to V into delta M by delta T. So that's why here mass change per unit time. Now, how much velocity it is flowing, I can say that M I can say that is equal to V into rho into G. Now, therefore, delta Pm by dt I can say that is equal to the volume flow, that is A area into X into rho into G by AdX by dt, which is VA into rho G. Since dx by dt is velocity, speed, so this I can say V into VA rho G. which is equal to rho A V square into G. So this will be the force that is exerted on the vertical wall just in front of the tube. So that force that will be equal to rho, that is 1000, that is 10 power 3 to A. Cross-sectional area, that is 10 centimeter square. It's 10 into 1 centimeter square, that is 10 power 1 centimeter is 10 power minus 2 meter whole square. 1 by 100, 1 by 100, that is 10 power minus 2 meter whole square. Is 10 power minus 4 meter square. 10 into 10 power minus 4 meter square, which is 10 power minus 3 meter square. So rho into 10 power minus 3 into V. V is 20. So 20 square into G. G is no, sorry, it is volume into density only. G will not come. G will not come. Rho A V square. G is not there. Rho A into V square only. So this is 400 Newton. So 400 Newton is the force that is applied on the vertical wall. Option D is the correct answer. Then here it is told, consider a cylindrical tank of radius 1 meter is filled with water. The cylindrical tank is there. It is having radius 1 meter. It is filled with water. Then the top surface of the water is 15 meter from the bottom of the cylinder. So then there is a hole on the wall of the cylinder at a height of 5 meters from the bottom. A force of 5 into 10 power 5 Newton is applied on the top surface of water. Here, this much force is applied on the top surface of the water using a piston. Then the speed of efflux from the hole will be speed with which water will come out. That will be found out. So the uh, pressure exerted here, the pressure exerted, that is this force is forced by the area, which is pi r square. P plus here the So here the velocity will be the speed with which water is going down, that is approximately 0 only. So P plus rho GH, rho into G into H is 10 meter. That is equal to P naught here, since pressure of the atmosphere is acting here near the hole. So PA plus half rho P square plus rho GH. But here if we take the zero level of gravitational potential, the ground level, if I take it here on this, so then this will become 0. Rho GH will be 0. H height will be 0. So then this will be pressure, that is 5 into 10 power 5 divided by radius, that is 5, which is 3.14 r square, is 1 square, plus rho GH. Rho is the density of water, it's 10 power 3, and G is 10. That is equal to PA, which is 1.01 into 10 power 5 plus half rho V square, half into 1000 10 power 3 into V square. So this P we have to find out, which is the speed of efflux in the hole. Now, if we divide both sides by 10 power 5, then we will get 5 by 3.14, which is 5, plus is 10 power 4 by 10 power 5. That is equal to 1.01, plus this will be 10 power 3 by 2 into 10 power 5 into V square. So therefore, this will be 10 power 2, which is 200. That means V by 200, that is equal to 5 by 3.14 minus this is 1 by 10, that is 0.1 minus 1.01. V will be equal to 200 into 5 by 3.14 minus 1.11, which will be equal to just V square actually is V square. This will be approximately 0.48 155 into 200. So V square is approximately 96.31. Therefore, V is approximately V is approximately 9.8 meter per second. V is actually approximately, so it is coming 5.5. Point 48 55 6.31. pi r square is 4 by pi r square plus 10 power 3 is the this here into 10 again will come, since why 1000 is the density and g is 10, and again 110 is there, 10 is the height. So this is 10 power 5 only. So 10 power 5 by 5, this will be 1. This will be 1 only. So it will be minus 1. V square by 200. That is 5 by 3.14 plus 1 minus 1.01, which is minus 0.01. The base will be V square will be equal to 200 into 5 by 3.14 minus 1.01. So this is 1.5836 approx. Therefore, V square will be approximately 16.47. V will be approximately square root of that. Which will be approximately 17.79, or I can say approximately 17.8 meter per second. So 17.8, option C is the correct answer. It is told uh, balloon has a mass of 10 gram in air. So its mass is 10 gram in the air. Then the air escapes from the balloon. One balloon is there. So through it, air escapes out from the balloon at a uniform rate with velocity 4.5 centimeter per second. So the mass of the balloon is 0.001 kg. Air escapes from the balloon at a uniform rate of this. If the balloon shrinks in 5 seconds completely, in 5 seconds it will completely shrink, the average force acting on that balloon will be the average force acting on the balloon. So average force, that is equal to, you can say, V dm by dt. Now dm, I can say that is small mass which is coming out per unit time. So that is say rho into dv. It has a mass of this much. Mass is 0.01 kg, and then So force will be equal to average force acting on that balloon will be. So we can say this is equal to actually V into delta M by delta T. So V is 4.5 into 10 power minus 2 meter per second. But you have to calculate in time. So we can keep the velocity in the CGS unit only. 4.5 centimeter per second into delta M, which is the initially the mass was 0. It was 10 gram minus the final mass that will be 0 by delta T, which is 5 seconds. This much the force. This much is the average force acting on the balloon in this ground. 5 is a 10, so 2 into 4.5, that is 9 grams centimeter per second square, which is 9 M. The force acting on the average force acting on the balloon is 9 M. So option B is the correct answer. Then it is told the force required to stretch a wire of cross section. The area of cross section is 1 centimeter square, and the force required to double the length. So the force required to double the length will be. That means here the extension, that is delta M, that is also yeah. So the amount of extension that will be also equal to L. If the initially the length is L, then the extension is also L. If the force F is applied, so the force required to stretch the wire to double the length. So the force required, that is obviously YA by N into delta. So this will be YA by N into delta L, which is also L, the same length of the wire. And L will get cancelled, and that will be YA. YA is the force required to stretch the wire. The force required to stretch the wire. So Y is 2 into 10 power 11 into A, that is 1 centimeter square. 10 power minus 2 meter whole square. So that is into 10 power minus 4, this much, 2 Newton. This will be 2 into 10 power 7 Newton. So option C is the correct answer. Then it is told that a steel wire of length, steel wire is there, its length is 3.2 meter, and the Young's modulus Y, that is 2 into 10 power 11 Newton per meter square. A steel wire is there of length 3.2 meter, and Young's modulus is 2 into 10. Young's modulus of steel, and a copper wire is there. Length of the copper wire, that is 4.4 meter, and the Young's modulus for copper is 1.1 to 10 power 11 meter per meter square, and both are having the radius 1.4 millimeter, which is equal to 1.4 into 10 power minus 3 meter, are connected end to end when stretched by a load. So suppose these two were they are connected end to end, they are being stretched by a load. Then elongation, the net elongation means the extension in the steel plus extension in the copper wire, that will give you 1.4 millimeter only. Then the load applied in Newton will be how much? So how much is the load that we will find out? So now we can say that we know that F is equal to YA by N into delta L. So therefore delta L, that is FL by A1. So therefore the force into the length of steel by area of cross section, which is pi r square, by Young's modulus of steel, plus the force into length of copper divided by pi r square into Young's modulus of copper, that is equal to 1.4 millimeter. So then F we have to find out. Now therefore F into, I can say, actually F by pi r square, that is coming as common. So it is Ls by Ys plus HCU by YCU. That is equal to 1.4 millimeter. It means 1.4 into 10 power minus 3 meter. So now therefore I can say F load F, that will be equal to 1.4 into 10 power minus 3 into pi r square. Pi, that is 22 by 7 into r. R is 1.4 meters. It is 1.4 into 10 power minus 3 whole square. Pi r square divided by Ls by Ys, and S, that is 3.2 millimeter by Ys, that is 2 into 10 power 11, and plus LCU by YCU, that is 4.4 meter divided by 1.1 into 10 power 11. So this we have to solve, then this much in Newton we will get the load, which is 7 2s are 14, and 2 into 22, that is 4.4 into 1.4 whole square, which is 1.96 into 10 power minus 3, 10 power minus 3 into 10 power minus 6 divided by, this will be 2, 16 to the 32, 1.1, so 4. So this is 1.6 plus 4 divided by 10 power 11, and that 10 power 11 will go up. So this much in Newton. So this is 5.6. I can take 4 lambda of 8, that gives us 16, and 4 11s are 44. So this is 1.1 into 1.96 by 1.4 into this is 10 power 11 minus 9 Newton, which is, you can say 14 into 14 is 96, so this would be 1.4 also. So 1.1 into 1.4 into 10 power 2 Newton. So it will be 11, you can say 11 into 14 Newton. So it is 11 4 is the 44, 11 1 is 11, so 154 Newton. 154 Newton is the required load that is being applied. And here it is told cylindrical vessels of equal cross-sectional area 16 centimeter square. Two cylindrical vessels are there of equal cross-sectional area, which is 16 centimeter square. Two cylindrical vessels of equal cross-sectional area 16 centimeter square contain water equal cross-sectional area 16 centimeter square. We contain water up to heights of 100 centimeter and 150 centimeter respectively. So here also the area is same, but here the height is 150 centimeter. The vessels are interconnected. So that the water levels in them are become equal. The work done by the force of gravity during the process is working by the force of gravity during the processes. Work done by the force of gravity that will be equal to the the total mass of the two the total mass of the water in the two vessels. M is the total mass of the water in the two vessels into G into delta H, where delta H is the change in the height of the center of mass of the system from the ground level. Delta H is the change in the height or the decrease in the height, change or I can say the decrease in the height of the center of mass of the system So the total mass of water in the vessels that will be area into H1. Here the height, initially the height is H1. Volume into rho, that is the density, rho H into rho into G. Plus this will be A into H2 into rho into G. This is the net mg into the delta H. So initially the center of mass of this jar, the center of mass of the water in this vessel was center of mass was at 50 centimeter height, and here the center of mass was at 75 centimeter height. So therefore the center of mass of the system was at a height of m1 x1 plus m2 x2 plus m1 plus m2 is ah1 rho into 50 plus ah2 rho into 75 by ah1 rho plus ah2 rho. So this was the initial center of mass height minus the final center of mass height, which is when it will flow, then what will happen? The volume will remain same. So it means I can say the height will become same only. So I can say V is A into H plus, so which is 2AH, that is equal to AH1 plus AH2. So I can say H will be equal to H1 plus H2 by 2. The height the final height of the center of mass, the final height of the center of mass. So that will be here masses will be same only. So I will say uh, m into h into h by 2 plus m into h by 2 by m plus n, that is 2m. And will cancel. So this is h by 2. So at h by 2 it will come. So h, where h is h1 plus h2 by 2. So it is h1 plus h2 by 4. So this will be at h1 plus h2 by 4. So this will be the work done actually. It is not the force. So it will be the work done by the force of gravity during this process. So this here A and rho I can cancel out. So it means we can say A rho G we can take as common into H1 plus H2 into this is 50 H1 plus 75 H2 by H1 plus H2 minus H1 plus H2 by 4. Plus H2 by 4. So this is the required work done. Here H1 that is 100 centimeter and H2 is 75. No, H2 is 150 centimeter. Now, this is coming in centimeter. Now, therefore, area that is 16 centimeters square. You can say 16 into 10 power minus 4 into rho, that is 10 power 3 kg per meter cube. into G, that is 10, into H1 plus H2, H1 plus H2, that is 250 centimeters. So 250 into 10 power minus 2 into this will be 50 H1, that is 50 into H1, that is 100 plus 75 into 150 divided by 100 plus 150. But this will be in centimeter, so it's going to be 10 into 10 power minus 2, so as to get them in silent. Then minus we will have H1 plus H2 by 4, which is 100, so 1 plus 1.5 by 4. So that is equal to the required work done. Therefore, this will be 16 into this is 10 power 4. So this two will cancel. 16 into 2.5 is equal 16 into 2.5 into this will be into 100. So this is 5,000 plus and right that this is 250. This is 50 into 100. Into 1 by 100 minus this 2.5 by 4, that is equal to the work done. This will be 40 into 0 will cancel. So 25 is a 50 and 25 is a 75. This will be 40 into this is 20 plus 20 plus 45 by 100 minus 2.5 by 4. It is equal to W, which is the work done, which you have to find out. So that will be 40 into this is 65. So 6.5 minus is 2.5 by 4. Is 65 by 100, so 0.65. Equal to this will be equal to 40 into 65 by 100 minus 40 into 25 by 2.5 by 4. 4 tens are 40. This will be 4 to the 4, 2 plus the 10, 5 ones are 5, 5 to 18, 13 to the 26 minus 25, which is 1 joule. So 1 joule is the required work done by the force of gravity during this process. Option B is the correct answer. Then here it is told the area of cross section of the rope used to lift a load by a crane is the area of cross section of the rope. Area of cross section of the rope which is used to lift a load by the crane, that is 2.5 into 10 power minus 4 meter square. The maximum lifting capacity of the crane, how much force it can lift, the force is 10 metric tons. 1 metric ton is 1000 kg. One metric ton is 1000 kg. This is 10 into 10 power 3. Kg. The mass it can lift, that is 10 into 10 power 3 kg. So therefore, the weight it can lift, the force, the load that can lift, that is equal to mg. G is 10, so 10 into 10 power 3 into 10, which is 10 power 5 Newton. So this is the maximum lifting capacity of the crane. To increase the lifting capacity of the crane to 25 metric tons, the required area of cross section of the rope should be. So we know that force is equal to YA by L into delta L. Now, maximum load it can lift. So if F will change, this delta L should not change. So the change in the length that should remain constant. The area of cross section can change. Young's modulus also cannot change. The length also cannot change. So it means that y delta L by L that will be equal to constant. Constant, so it means that F by A that should be constant. Since y, then only the lifting capacity will increase. So therefore I can say F1 by A1 that should be equal to F2 by A2. So therefore F1 that is 10 power 5 divided by when the area of cross section that is 2.5 into 10 power minus 4 meter square is equal to the force that is 25 metric tons, means 25 into 10 power 3 kg into g, that is 10 divided by the area of cross section which is required, A2 that we have to find out. So A2 will be 2.5 into, I can write 10 power 5 2.5 to 10 power 5 into 2.5 into 10 power minus 4 divided by 10 power 5. 10 power 10 power 5 will cancel, so this is A2 will come 2.5 whole square, that is 6.25 into 10 power minus 4 meter square. It means option A is the correct answer. Here it is told that water drop of radius, there is a water drop in radius 1 centimeter. It is broken into 729 equal droplets. We have 729 equal droplets. Now, if the surface tension of the surface tension of the water is 75 dyne per centimeter. So dyne per centimeter means 75. Dyne means gram centimeter per second square per centimeter. So it is gram per centimeter square. Gram per second square. So now the surface tension is 75 gram per centimeter square. So now then the gain in surface energy, that is given as S into delta A is the surface tension to change in the surface area that we have to find out. The surface tension that is 75 gram per centimeter means 75 I can write into 10 power minus 3 kg per second square. It means or I can say 75 into 10 power minus 3 Newton per meter. Newton per meter. This is 7.75 into 10 power minus 3 into change in the surface area, that is equal to 4 pi r square minus 4 minus 729. Simply I can write 729 into 4 pi small r square minus 4 pi capital R square. The gain in surface energy up to first results. So now here we can conserve the mass. So by law of conservation of mass, you can say the mass will remain unchanged. And since the density is same, so the volume also will be unchanged. Means the initial volume equal to the final volume, means 4 by 3 pi capital R cube, that is equal to 729 into 4 by 3 small r cube. 3 pi small r cube. So 4 by 3 pi 4 by 3 pi will cancel. So r cube is equal to 729 means 9 cube into r cube. Means r is equal to 9r. Is the radius of the large drop, that is 9 times the radius of each small droplets. So this will be equal to 75 into 10 power minus 3 into 4 pi, that is 4 into 3.14 into 729 into r square. Radius is 1 centimeter, which is 0.01 meter. 0.01 meter. R is this. R is equal to R by 9, I can say, which is 0.01 by 9 meter. This is 4 pi. You can take it outside. So 729 into 1 by R, 729 into R square. So R square will be 0.01 by 9 whole square. Minus R square, which is 0.01 whole square. It is much joule will cut. So therefore delta E, that is equal to 75 into 4 into 3.14 into 10 power minus 3 into, that will be 789 into, this will be 10 power minus 4 divided by 81 and minus 10 power minus 4. So 81 into 9, that is 729. So then from here, this becomes 75 into 4 into 3.14 to 10 power minus 3 into 10 power minus 4 into 9 minus 1, that is 8. It's not joule. So then we will gain. Therefore, the change in the surface energy, that is equal to 75 into 4 into 3.14 into 8, 5,000 into 10 power minus 4 joule. So now 4 with 4 I can cancel. 4 2s are 8, 4 5s are 20, 0. And then with 25, 25 10s are and 25 3s are and 8. Okay, so 8 with this. So this will be, so 3 8s are 24, 24 into 5, 3.14 divided by 10, so 2.4 into 3.14 into 10 power minus 4 joule. So 2.4 into 3.14 that we have to find out, which is approximately 7 point something, 7.5 approx. 7.5 approx into 10 power minus 4 joule. 2.5 into 10 power minus 4 joule. So option C is the correct answer.